To everyone watching this video, hello. My name is Grayson, and this is my Week 1 Physics 2211 lab report video. The purpose of this lab is to observe motion of an object moving at a constant velocity. To observe this, I used a racquetball and pushed it across a flat surface so it was moving at a constant velocity over the duration of the clip. This clip demonstrates a momentum principle, or Newton's second law. Using the aforementioned principle, we can conclude that since the object is at a constant velocity throughout the duration of the clip, the sum of the forces acting upon the ball, also known as the net force, is zero. Again, the main principle demonstrated in this experiment is the momentum principle. The momentum principle states that a change in momentum in a system is equal to the net interaction, or the force, acting on the system by the surroundings multiplied by the duration of the interaction. Again, this is also known as Newton's second law of motion. To put this into formulaic terms, this is the same as saying that the change in momentum of an object is approximately equal to the net force upon that object multiplied by the time over which that force was applied. This can be then rearranged to say that the change in momentum of an object divided by the change in time of that object is approximately equal to the net force of that object. If we look at this formula as the change in time equals zero, we will get the derivative of momentum with respect to time, which gives an exact net force at said time. Then, knowing that momentum equals mass times velocity, we can further break down this equation into mass times the derivative of velocity with respect to time. This graphic helps explain what is going on in the experiment. Since the initial and final momentum are the same, the change in momentum is zero. And since we know that the force equals the change in momentum over the change in time, if we are dividing with zero in the numerator, we will have zero as our answer. This means there is no net force. In this experiment, the racquetball is the system. Everything else, which could include myself, the earth, the table that it was rolling across, the air that was moving around in the room, everything else is classified as the surroundings. I decided to use a racquetball for this experiment because it is round, so I know it won't have any issues rolling across the table, and it has a known mass, so I can easily calculate the momentum. By the way, its mass is 40 grams or 0.04 kilograms, if you were wondering. There are no assumptions being made in this lab because everything we did here is provable with calculations that we are certain about. In fact, the only calculation that was made is one to show that the net force was zero. Using our formula that we talked about earlier, Newton's second law, the derivative of momentum equals net force, or in simpler terms, the change in momentum over change in time equals net force. And really why we did this is because the purpose of this lab is to show that an object with constant velocity. At the start of the clip, the ball is rolling in the positive x direction with a velocity of 0.6436 meters per second, or 64.36 meters per second. There is no change in the y or z directions. In fact, all that really happened in this experiment was I pushed the ball and it rolled across the table at a constant speed. In my glow script code, I made the mass of the ball 0.04 kilograms, as that it was its mass. Also, I changed the velocity to be 0.6436 in the positive x direction, because that was its initial velocity. I changed the delta t to 0.867 divided by 26, because the total time over which the ball was rolling was 0.867 seconds, and it moved over 26 frames. For my update position formula in GlowScript, I use this really long and confusing looking number because that was how much the position changed within the first frame of my object moving. When we compare the tracker data and the Python data side by side, we can see that they are both very similar. The main reason that they are any different at all is because there is a slight inconsistency with me clicking the center of the ball when I was clicking for position updates within tracker. We can also see how similar they are by looking at their graphs. Both of their positions are changing by moving upward with the same constant slope. This constant slope means that the derivative of position is zero, which means that the velocity is zero, which means that the net force is zero. If I were to have changed the plus and minus x-axes, this would have just meant that my ball would have been moving in the negative x direction. This would have had no change on the net force, as the velocity would have still been constant. Also, at the time that the ball is rolling, the only forces acting upon it are the pull of the earth and the push of the table. In conclusion, we can see that an object with constant velocity has a net force of 0. I hope you enjoyed this video and have a nice day.